Okay, here is a big skill that we're going to go ahead and be applying quite a bit throughout the section here, and it allows us to go back and solve some of the problems that we weren't able to do earlier on in the course. And so therefore, here we go. First things first is that we want to use the natural log, or logs in general, but just natural logs right here, to solve exponential equations. So the way that we did it before is that we equated bases. That means is that our assumption is that, say if I take this example right here, is that if we could get the bases the same. So if I could rewrite 1/16 as some power of 2, then I could equate the bases and then equate the exponents. And so what we did is that we went 2 to the 2x minus 5 power equals, and how am I going to write 1/16 as a power of 2? So I could go 2 to the 4th power is going to be 16, but I need that 2 to be up there so I can make the 4 negative, and that's going to give me 2 to the negative 4th. And so therefore, now I can say, all right, since these bases are the same, okay, the exponents must be the same as well. So I went 2x minus 5 equals a negative 4. Add 5 to each side, and I got 2x equals 1, and then at the end of the day, x equals a half. So the problem with this method is that we need to be able to set up the like bases, and that's not always easy. And so therefore, we're going to go ahead, and I'm going to show you that this method, by taking the natural log of both sides, is going to work equally the same. Okay, so the first thing that we want to do is that we want to take a look at this property here in the bottom corner. Okay, and the property that we're interested in is this guy right here. Okay, because that allows us again to take that exponent and put it out in front of the natural log, so it's no longer an exponential position. That's going to be powerful, and I'm going to show you why that is. So what we're going to do is that we're going to take the natural log of both sides, just like we'd be multiplying through by something, or adding or subtracting something to both sides. We can take the natural log of both sides as well. Okay? So I have this, and notice that I got the natural log of 1/16 over here. So what happens that's clever about this is that the exponent comes out in front, and we are going to be left with then 2x minus 5, okay, times ln 2, okay, which is this part, what's left, equals ln of 1/16, okay? So we can start knocking this thing out. What I'm going to do is that I'm going to divide each side by the natural log of 2. Okay, and that's going to cancel these guys out, and I'm going to get 2x minus 5 equals. Now I'm going to put this part right here into a calculator, and that's going to give me, okay, that's going to give me a negative 4. Oops. And from here, I just solve it out just like I did on the left-hand side. So I add 5 to each side, and then I divide by 2, and x is 1/2. So what we're really looking at is that taking the natural log of both sides works for any exponential equation. So let's go ahead and give the next one a try. And it's not always going to be really nice answers, and that's okay. And we're going to do some rounding out to the nearest. Probably. Okay, for this guy, if I want to use the natural log, taking the natural log of both sides, what I have to do is I have to get the term that has the exponential stuff all by itself. Okay, so the first thing that I want to do is move anything that I can to the other side, like for example that 10, and that's going to give me e to the negative x plus 4 power equals 12. Okay, so now I want to take the natural log of both sides. So that is going to give me the natural log of e to the negative x plus 4 equals the natural log of 12. Okay. As we planned, this comes out in front, so we can actually solve for that variable. And I have a negative x plus 4 times the natural log of e equals the natural log of 12. Okay. Now, here is something that we need to remember. Well, one of the properties is that if, and I know it's a little blurry right here, but if I have the natural log of e, that is going to equal 1. So this is actually just 1. So I can say then a negative x plus 4 equals the natural log of 12. Okay. So to solve this out, I'm going to subtract 4 from each side. And when I subtract 4, watch what I'm going to do here, is that I have the natural log of 12 and then minus 4 out here. It doesn't subtract it from the 12, all right? And then I want to multiply each side by a negative 1, and that's going to give me, to get rid of that negative, so I'm going to have a negative, flipping all the signs here, and that's going to be my exact answer. So if I want to find out approximately what that is, I have to put it in a calculator, and that's going to give me approximately, so 1.515. Okay, so again, this one is going to be the exact solution, whereas this is the approximate. Okay, so some of these problems are going to need a little bit more setting up than others. And so to do the next one, what we need to do is we need to start moving things away from, again, that exponential term right there to get it all by itself so we can take the natural log. So here we go. Let's subtract by 8. Okay, and I got a negative 2e to the 3x plus 4 power equals a negative 2. And then I'm going to divide each side by negative 2. Those are going to cancel out. And I'm going to put my answer over here because I'm a little bit pressed for room because of those bubbles. And so we got e to the 3x plus 4 equals 1. Okay, so I'm going to take the natural log of both sides again. So I go natural log of e to the 3x plus 4 equals a natural log of 1. Now, a couple neat things are going to happen here. This is going to come out in front, like we practiced. Okay? And I have the natural log of e left over right here, and then the natural log of 1. Now, the other definition of the natural log of 1 is 0. And we have, again, the natural log of e, which is going to be 1. So this is actually just going to be 1, and this is going to be 0. So that's going to give me 3x plus 4 equals 0. Okay, and then solving that out, I'm going to subtract 4 and divide by 3, and that's going to give me x equals a negative 4 over 3. Okay, and that now I don't really need to put it in a calculator because obviously it's already done. And yeah, so something else that's very interesting about this, and I'm going to go back to one of the assignments and to show you how to use this to find some of the stuff that we couldn't before. Okay, so here's one of our solutions that was from our exponential practicing, and notice that we had the x-intercept stuff all blank. Well, now we can go back and find all those, and this is how we would do that. If you recall, finding the x-intercept, we would let y equal 0, so I'd have 0 equals e to the x plus 3 minus 4. Now, like we just learned, we want to get this part all by itself. Okay, so I'm going to be adding 4 to each side, and I'm going to switch them around just because quality of life here. Just leave it as is, not that big of a deal. E to the x plus 3. So now I'm going to take the natural log of both sides, and that is going to give me the ln e to the x plus 3, and that x plus 3 is going to come right out in front like this. Okay, and so I would have ln 4, then I would have x plus 3 over here, and then ln e. Now ln e, we know from our properties, is going to be 1. ln 4, though, we don't know what that is. We're going to have to use a calculator in a moment to find out what that is. So I have ln 4 equals x plus 3. So I'm going to subtract 3 from each side, and I'm going to get x equals the natural log of 4 minus 3. Okay? Now, we're hoping that since our final answer here is our, if we look at this graph, here is where our x-intercept is at. So hopefully we're going to get something in between a -1 and a -2. So let me punch this in our calculator, and we're going to get, okay, we're going to get that x is approximately a -1.614. Okay? And so I can finally go back and fill this in without using the Desmos graphing program or anything of that sort to define that. And it looks like that seems pretty reasonable. Okay, so what we want to do is that if we weren't able to find those x-intercepts, and there were x-intercepts to find on these graphs, then we can go back and use this technique to find those. There's also going to be a follow-up lesson that we already started, and it looked like this. Because before, we were able to do all of these guys right here by doing that equating coefficients. Now we can go ahead and we can start to do them out with the natural logs. And so we want to go back and finish that up and see where that takes us. Okay, so finishing the right-hand side of that particular assignment. So again, to reiterate, we go back and we are going to find the x-intercepts of our graphs and then go back and solve these out as well. Okay, so that's how you do that. And thanks for watching.